so again, check Google Classroom in the description part of the post to see what page to glue this in on in your notebook. But we are going to be talking today about triangle classification. So this is something that should be a review from previous years, but we're going to go through it again and then have it in our notebooks to reference in the future. So there are two ways that we can classify triangles. We can classify them by their sides and we can classify them by their angles. So up at the top, we have scalene, isosceles, and equilateral. These are all ways that we can classify a triangle by its sides. Then down the other column, we have the classifications for their angles. So acute, right, obtuse, and equal angular. You can always classify a triangle using two terms. However, one has to be a side, the other one has to be an angle description. So you cannot have two side descriptions to classify a triangle. So let's get into the specifics about them. So when we talk about sides, if a triangle has no congruent sides, it is called scalene. Congruent again means equal. So if none of the sides in the triangle are equal, it is called a scalene triangle. Isosceles means at least two. So remember, at least means two or more. So at least two of the sides in the triangle are equal. And an equilateral triangle has all three sides congruent. So every single side on that triangle is equal to one another. Okay? When we talk about acute, in order for a triangle to be classified as acute, all three angles have to be acute, or a measure less than 90 degrees. In order for a triangle to be considered a right triangle, only one of the angles measures 90 degrees. The other two are acute. An obtuse triangle has one obtuse, or one angle that is greater than 90 degrees, and then the other two are acute. And an equal angular triangle has all three angles equal the same, and they are all three acute. Okay? So we're going to add a little details to it. So if I have a scalene acute triangle, that means all three of my angles are less than 90. So looking at this picture right here, they are all three less than 90 degrees. And none of those sides are equal. Now, if I have an isosceles triangle, which means two of the sides are congruent, so let's add in two tick marks. And all three of my angles are still less than 90, therefore it is an acute isosceles triangle. And then my equilateral triangle, I have all three sides are equal, and again, all three angles are less than 90 degrees. Okay, now if I go down to the next row, I have a right triangle. So let's draw in our box to indicate that is a right angle. One of the angles is 90 degrees, the other two are acute, and since it's a scalene right triangle, none of the sides are congruent. Over here, I have a right triangle that is isosceles, and this one to draw in this is your right angle up top. So let's draw that in. And then these two sides are congruent to each other, so it is an isosceles right triangle. You cannot have a right triangle and have an equilateral triangle. It is not possible. So that is why they have that red symbol. For the next row, we have an obtuse triangle. So that angle is our greater than 90. The other two angles are less than 90. And it is scalene, which means it has no sides congruent. Over here, I have an obtuse isosceles triangle. So I have one angle that's greater than 90. And then I have two sides that are congruent. And again, you cannot have an obtuse equilateral triangle. It is not possible. Down for equiangular, You cannot have an equal angular triangle, which means all three angles are the same, and have all three sides be different. It's not possible. But for isosceles and equal angular, all three of these angles are congruent. And then actually on this one, all three of the sides are congruent as well. Because remember, isosceles means at least two. And then lastly, our equal angular equilateral triangle, all three sides are congruent and all three angles are congruent. Notice that these two pictures are the exact same. So the best description for this one is actually an equilateral equal angular triangle.